So in continuation of our previous video, now we will start with question 4, sub question 1, and here 10 questions are there. We have to prove the identities. Yesterday 3 identities we have discussed, so out of that we have to use the identity and prove it. So here you see, here cos is coming. It means somehow we have to reach to cos. So for this we will apply cosec. Cosec is opposite of your sine. So here we can write 1 upon sine and theta or angle A. If sometime I miss, you just think it is written there. Okay. And here cot we can write is cos upon sine. And if theta is missing, you presume theta is there. Okay. Because everywhere theta or angle A is there, we have to write. Then this sine and sine are there, so we can take it as a LCM. So equal to what we can do, we will treat it as a sine as a LCM, sine theta as a LCM. So what will happen? 1 minus cos will remain, 1 minus cos theta will remain, and it will be in underscore. So here this square is on both, on it and on it also. So on the upper side you have got 1 minus cos theta and square is here, and in the downside also sine square, it will become sine square theta. Okay, so here 1 a minus b whole square is there. So this sign we can change. Sine, now we know that sine square plus cos square equal to 1. Okay, so this sine, suppose we want to change, so we can make it sine square is equal to what will happen? 1 minus cos square. So we are getting, so here we will change it, sine square we will change. So we will change sine square at 1 minus cos square. Okay. Now 1 minus cos square has come here, and upper side also it is there. So 1 minus cos, we can write it like this also, 1 minus cos theta, and it is 2 square means 2 times we have to write, multiply by bracket we can show 1 minus cos and theta is there. Okay. And here 1 minus cos square is there, sine equal to this we can use. So the next step, what we will do, 1 minus cos theta, this is in one bracket, and 1 minus cos theta. Now here a square minus b square we can take, identity we can use a square minus b square. So what will be there? A plus b and a minus b. So 1 minus cos will be in one bracket, and 1 plus cos theta will be in, suppose theta I am missing, so you put it. So now we can cut. So what will remain? 1 minus cos will remain, 1 plus cos theta will remain. So you have proved it. So what will 1 minus cos theta, and up lower side 1 plus cos theta proved. Okay, so the 1 minus cos square, 1 plus cos, so it is proved. So this is, now we will go to question number 4 and sub question 2. So question 2 is cos A upon 1 plus sin A, and 1 plus sin A is here also, and cos A is here also. So what we can start? We will start with the LCM of this. So LCM we are taking 1 plus sin A and cos A. This is your LCM. Okay, LCM we have taken. So if you divide it, cos A will come and cos A will multiply it. So it will become cos square A. It will become, and here if you divide with it, what will remain? 1 plus sin A will remain. So 1 plus sin A and 1 plus sin A will multiply. So it will become 1 plus sin A and its whole square. Okay, it will become like this. So now we will expand it. So cos square A plus b whole square, we can use identity. A plus b whole square. This identity we are now using. So it will become 1 square plus sine square a plus 2ab, 2 into 1 plus sine square. It will become. And lower side what will happen? 1 plus sine a. Sine a will. Okay. So cos this we have got. So now what we can do? This now we are okay. So this identity we are using a square plus b square plus 2ab. We are using this. So now this this is so it will be 1 and 2. So cos square a plus 1 will remain 1, and this plus 2 plus sine square a plus 2 sine it will become. So 1 plus sine, 1 plus sine square. Here cos square and sine square. Sine square plus cos square we can write 1. So what will happen? Cos square plus sine square we are making 1. So 1 plus this one will also remain plus 2 sine upon 1 plus sine a into cos a. So what will happen here? 2 plus 2, it will be 2 plus 2 sine a upon 1 plus sine a and cos a. Cos a. So here 2 you take the common out. So we are taking 2 as a common out. So 1 plus sine a will remain, and here what we will remain? 1 plus sine a and cos a will remain. Now you can cut, because here multiply sign is there, we can cut it. So 2 upon cos a is coming. 2 upon cos a. This cos a we can write it as a 2 upon cos. Cos is equal to 1 upon, because it is opposite of sec a. Now sec we are getting. So further we can, it is in divide portion, we can take it to the multiply side. Sec a upon 1. So it will be 2 sec a, and this you have to prove, and we have proved it. Okay. In this way we can prove it. So now we will go to question number 3rd. So here we will start, we will make it change, some change here. Tan theta upon 1 minus cot. Cot we can write it as a tan we know tan is equal to cos, sine upon cos, and cot is equal to, so in place of cot we can write cos upon sine. Yes, here cot is there, upper side first we are not changing, and here 1 minus tan we can write it sine upon cos. Okay, so one side R, this is your LHS, left hand side it is your RHS, right hand side. Okay, and this will put LHS equal to right hand side, we have to prove the identity. Okay, so here now we will take LCM of it and LCM of it also. So tan theta, we can write the LCM sign. LCM sign, this is your LCM. LCM, so 1 will become sine. Because 1 upon 1 is there, 1 will divide sine and sine will multiply 1. Okay. Minus cos. It will remain. And plus this side cot theta. If theta is missing, you presume theta is there, because sometimes due to time saving, I don't write it. So you have to write that every step you have to write. So here also we will take cos as a LCM. Cos as a LCM we will take, and it will become cos minus sine theta. Okay. Now your next step. After this, what we can do? So this we will take to the upper side. What we will do? Tan theta into sine theta upon sine minus cos, plus this cos we will take upper side. Cot into cos theta upon cos theta upon cos minus sine will remain. Cos theta minus sine theta will remain here. Okay. Now our next step will be, this is the same, but this minus sign is not here. So what we will change this sign. Tan theta into sine theta upon sine minus cos theta, and we will put it in a minus sign. So what will happen? This all will go to here. No sign is there, so cot into cos theta, and it will become minus. Its sign will become minus, it will become plus. So we can write it sine minus cos theta. We can write it. Okay. So this sign and this has become agreed. Now what we can do? We will make a LCM of it. So now for this sign we are changing it. So tan we can write is sine upon cos. Sine upon cos into sine theta. Okay. Upon sine minus cos. Okay. Here we can, cot we are changing, cos upon sine into cos theta upon sine theta and cos theta. Okay. This line, now some upper portion we will remove, and from here we will go to the upper side. Okay. From this will be our baseline. From here we will start. So this line will change to sine square upon cos. Sine square upon cos it will become. And this sine minus cos will of course remain. Sine minus cos will remain. Minus sine. Now this also cos square it will become cos square, and sine will remain there. Sine and whole upon sine square cos square. Minus cos theta. Okay. So this line will change to it. Now I am rubbing this line also. So it has changed. Now from here we will go further. So sine minus cos is here. So cos sine upon cos is here. So now we will multiply both the side with sine and cos. Multiply. So what will sine and cos will multiply this also. So sine square upon cos into sine cos, and it will cut it. Okay. So this it will multiply both the side, numerator and denominator, both the side it will. So what will happen? This sign will go out, and here upper side it will become sine cube. It will become what? It will become sine cube, and here it will become cos cube, and lower side it will become sine minus cos, and other will remain sine dash cos, and other this we have multiplied, sine and cos will remain. So now here we will use the identity a cube minus b cube. A cube minus b cube is a minus b and a square plus b square plus ab. This is our formula. So this formula we will use here. This identity we will use here, algebraic identity. So here it will become sine minus cos, so that we can cut it. And in other way, sine square plus cos square plus sine cos, sine and cos upon lower side, sine minus cos, and other is sine cos, sine and cos. So what will happen? Sine minus cos. So now this will go out. What will remain? This portion will remain with you. From here we will again go to the here and we will do the rest. Or here we can write sine square plus cos square plus and here it will be sine cos, sine and cos. And lower side what will remain? Sine cos will remain, sine and cos will remain. Now I am rubbing and we will go further. From here we are writing now. So sine square plus cos square equal to 1 we can write, plus sine cos we will write. And lower side also it is sine cos. But here we cannot cut it because multiply sign is not here. So this portion is below 1 also and below here also. It means 1 upon sine cos plus sine cos upon sine cos. So here now you can cut it. So here we can cut it. So here we will cut it. So what will remain? 1 upon sine and cos will remain. So here if you will cut 1 upon 1 means 1 will remain here. So this sine cos we can make it as a 1 upon sine into 1 upon cos we can make. So it will become 1 upon sine cos. Plus 1 will remain here and 1 will remain here. So 1 upon sine is opposite to cosec. So it is cosec, and 1 upon cos is equal to sec. So into sec plus 1. So 1 plus sec plus cosec. So this you have to prove 1 plus sec theta and cosec theta, and it is proved. Okay, now it is proved. Now we will go to our question 4 and part 4. Okay, side we will starting first. So 1 plus sec we can write it. Sec is the opposite of cos and sec are opposite. So 1 upon cos upon sec we can write. So here LCM cos we are taking LCM cos, LCM we will take, so it will become 1 upon cos, so it will make it cos plus 1 whole upon sec, it will become sec. Okay, cos plus 1 upon, now cos and sec also we can write it 1 upon cos. 1 sec we can write 1 upon cos. So next step, cos theta plus 1 upon cos, and this will go to upper side into cos upon 1. So now we can cut it, and what will remain? Cos plus 1. Cos plus 1 will remain. So this is one side. It is one side. Now this side we are solving, because directly it has not come. So what we will prove it to something, and if this also will come to something, then both will be equal. So here this identity we will use, and we will make sine square. We can write it 1 minus cos square. So we will write sine square is equal to 1 minus cos square, and here 1 minus cos. Of course a is there, cos minus a is there. So 1 minus cos, here identity we can use a square minus b square, because 1 we can treat it 1 into 1 means 1 square also we can treat it 1 square. It is 1's special property. So 1 minus cos a, 1 minus cos a, we can 1 minus cos a. So we can write it 1 minus cos a in one bracket, and in another bracket 1 plus cos a upon 1 minus cos a. So this will remain. Okay, a square minus b square means a plus b, a minus b. Okay. So now we can cut it. This we will cut it, and 1 will come here. So 1, if you will multiply the both thing, it will remain as 1 plus cos a. Or we can write it cos a plus 1. So here also it is cos a plus 1, cos a plus. So here your LHS is equal to RHS. So this is proved. So proved. Okay. It will be proved here. This and this will be equal, because here your LHS and RHS are equal. Now we will go to question number 5th part. So first we will solve this side, and we will divide it by sine. Divide by sine. Divide by sine. So by plus and minus it becomes a separate term, and if you divide, it will divide every term, means it will become cos a upon sine, and it will be sine upon sine it will become, and it will become 1 upon sine. Okay, and here also cos a upon sine, everywhere it will divide, plus sine upon sine minus 1. So if we will cut it, it will become 1. If we will cut it, it will become 1. So how it is going? Cos upon sine. So 1 will come, right? Cos upon sine minus 1, and 1 upon sine, sine's opposite is your cosec. So we can write it as a cosec. Okay, and in the lower side cos upon sine plus 1 will come, and here 1 upon sine, again we can write it as a cosec. Okay. So here cos upon sine we can write it as a cot minus 1 plus cosec. And here also cos upon sine we can write it as a cot plus 1 plus cosec, we can write it. Cot minus 1, we have a formula, we have an identity, cot square plus 1 is equal to cosec square, is equal to cosec square. This is one formula. So cot plus 1 we can write it as a cosec square, and here cot minus 1. So 1 if we will take, so we can write it cot, and minus sign if we will take out. So now it will become a plus sign. If minus sign and 1 we will write, we can write it like this. So if 1 is positive, we can write this 1 equal to cosec square minus cot square. Okay, this we can write here. cosec square minus cot square. Okay, this we have inflated plus cosec upon. Here cot plus 1, cot plus 1 is equal to cot plus 1 is equal to cosec square. Cosec square plus cosec. Okay. Now I will rub, and from one line also we can use, more one line we can use. So cot square minus cosec is there, so, and it is also here. This plus cosec and cot we are merging. Cot plus, क्योंकि multiply in addition, if you will, it is the property of addition, we can shift this side, that side. Cot plus cosec in one place we are taking, and minus this we are taking in another side. Minus now we will rub it, and from this step we will go further. Means up to here we will rub. Okay. Now here a square minus b square is here, so we will use the identity a square minus b square, and this we are putting in one bracket. So equal to cot plus cosec, and this a square minus b square means it will become cosec minus cot, and cosec plus cot it will become, upon cot plus 1, cot plus 1 minus cosec it will remain. Okay, or we can okay. Now so here we will take cot plus cosec as a common we are taking out. Cot plus cosec, this is your common, it is common we have taken out. This and this common we have taken out, so what will remain? 1, it is 1, it will divide it and 1 will remain, and this will go and it will remain, minus cosec minus cot, it will remain, and lower side it will remain like this, cot plus 1 minus cosec. Okay, so here if you will open the bracket it will become minus and it will become plus, cot plus cosec, and this will, we will open it, bracket will open, so it will become minus cosec and it will make it plus cot. Okay, upon cot plus 1 minus cosec. So here you see minus cosec is here, 1 positive is there, cot positive is there. So, and here the multiply sign is also there. So we can cut it like this. Okay. So what will remain? It will remain cot and cosec will remain here. 1 upon 1 means 1 will remain here. So if 1 you will multiply it, it will remain cot plus cosec. So cot A plus cosec A. It will remain, or we can say cosec A is plus cot A we can write. And this is your proved. This is proved. Okay. And this side is not required because it is further we have taken it to upper side. So like this your up to 5th is over. Now question 4 and 6 onward we will be in the next video we will put. Okay, thank you. Okay. Now thanks for watching my video. Please share with your friends also so that they can also subscribe and share with their friends also. Thank you for watching.